Hey guys, hey, so going to be doing another one of those notes, like highlighting videos. Really like the first one, maybe kind of helped me kind of organize my thoughts, and like it's nice to have like a record of how I actually did. So if I ever like have to study and like, wait, how do I do this? I can go and look back at that. So today, I've actually pretty much done with all of my exams. I only have one left on Monday, today, Saturday, and that's chemistry. Yay! The hardest one, pretty much. Well, the second hardest after physics. So I'm gonna highlight, but I think one of the things about chemistry and physics is that you have to learn a lot of like definitions, and you have to know them like off by heart, word for word, and then like they could ask you maybe 4, but you have to learn like 50. So that's one of the things where you really have to drill it into yourself. So I thought it would be interesting to see how I highlight that. So this pack of notes, like I made it a while ago, but it hasn't been highlighted yet, so let's go. First of all, I highlighted the heading organic chemistry in blue, which I always do. And then the little definition of that, let me get my pink. Chemistry of carbon and its compounds. And then definitions I'm also going to highlight in blue, like with a little line rather than the thick one that I did for the main heading. And I will go into a bunch of them. So I usually use these 3 colors. Maybe this if I have a diagram or something, but I don't really. Maybe because I have something, so I'll get to that. This for like the subheadings, and then this for the teensy things that I have to make notes of. So, for example, let's start here with hydrocarbon. A carbon containing only carbon and hydrogen atoms. So I'm going to highlight a compound, only carbon and hydrogen atoms. Then if you go to saturated compound, a compound in which all of the bonds between carbon atoms are single bonds. Then I have an example for that, which is like alkanes. So a compound, all of the bonds are between carbon atoms, single bonds. And then I'm going to take my orange, which I use for like specific things like this, and I'm going to highlight alkynes because that is something that I should make separate note of. I drew like a little box around it in orange. And then if you go into unsaturated compounds, a compound in which there is at least one double and or triple bond between carbon atoms. So carbon, at least one double or triple bond, and carbon atoms. Then take the orange again and then highlight the example, which is alkenes, another box around that. So like that's how I like to do my like definitions. So I highlight like the keywords, and then I would, if I have like a diagram or something, I do that in orange, so it's very like easy to understand. So I could like take like a quick look at this and be like, okay, I need to make notes of that. Because oftentimes when it comes to definitions, like one of the hardest parts to remember is like the exact wording of it. So like, I know this sounds crazy, but like there have been times where I've lost the mark for a definition because I said like on instead of in or something like that. So those little words or stuff that I have to make notes of, I feel like when it comes to like the bigger picture, when it comes to like learning so many definitions, it's better to pay attention to like the keywords, because like when it comes to the exam, let's be honest, those little things like you can never learn them all. So keywords is what's most important. And then let's go on functional group. an atom or group of atoms, that form the center of chemical activity in the molecule. So atom, a group of atoms, center of chemical activity. Okay, then here's a long one. These long ones are really like one of the hardest parts when it comes to definitions. Homologous series, a series of similar compounds which have the same functional group and have the same general formula, in which each member differs from the previous one by a single CH2 unit. That's a lot to remember, so let's break it down. So, series of similar compounds, same functional group, same general formula, and differs from the previous on. Oh, I forgot. I made a typo. I said on. I should say one. Yes, fix that. Differs by a single CH atom. Okay, I think I can remember that. But usually the longer ones like really just go off my brain. Structural isomers, compounds that having the same molecular formula but different structural formula. So pretty simple. Same molecular formula, different structural formula. Then onto this was something that I started doing recently. I don't have it in all of my notes, but I feel like sometimes you need to like draw it or like illustrate it better when it comes to definitions, because with definitions you can know like the words of it, but if you don't know how to like take those words and like use them in equations and stuff, it becomes pretty like hard to actually know what you're doing. So I thought I made like a little thing of here at the bottom. This is isomers and then like the definitions of all of them, and then here I showed like an example of all the different types of formulas. So highlight isomers. First one, chain of structural isomer, different structures. I'm going to do this. I highlighted chain in pink, so I'm going to do the thingy in yellow. Different structures, i.e. branching, and then I'm going to highlight the examples in orange. Butane versus methyl propane. Yeah, methyl propane. Second one, positional, different position of functional group. Position of functional group. Just like butane 1 or butane 2. And then, last but not least, functional isomers, different functional group. Like propanoic acid or ethyl methanoate. This must make no sense to someone who doesn't do chemistry. Like, what are these words? Propanoic acid? What's that? And then the examples. I think I'll do the name of the example in pink and then highlight the example in orange. Yeah. So structural formula. That's like the one where it actually shows like the shape of it. Where like you draw and then you show all of the bonds versus a condensed structural formula. So it's pretty much when you take the structural formula and just like put like it out in the letters with the bonds is going left to right, and then the molecular formula is pretty much like the condensed structural formula but like condensed, so you group it all together rather than having like here we have like CH3, CH2, COOH. Like you just bring them all together to C2, C5, COOH. No. H5. Gosh, I keep making typos. Where's my pen? Yeah. So that's C2, H5, COOH. And COOH is different because that's the functional group. So yeah, I think this is like a pretty good method to do it, where you go from, you know, the main heading, the subheadings, you do all the keywords, examples, and then you you know, show it all so you know what's going on. This is so awkward. I think that's a good ending.